Hello, YouTubers, and thank you for stopping by Courses in Computers on YouTube and subnetting.us on the World Wide Web. And today we're going to give a introduction to binary numbers. Now, you may have taken a look at the video that I had out before, which was describing base 10 numbers. Those are all of our decimal numbers from 0 to 9. So a number like 678 is a base 10 number. And if you just were watching that, then the review here is you know that this number is 600 plus 70 plus 8. And we went through a detailed explanation of how those numbers are broken down, and it really comes back to something that you probably learned a long time ago in school about a ones place and a tens place and a hundreds place. So that stuff is great to know. Give me just a second here. That's sort of making stuff disappear. There we go. So that stuff is really great to know because, again, when we have a decimal number like 17, it comes down to 10 plus 7. And that is broken down to 1 times 10 to the first power plus 7 times 10 to the 0 power. We went over any number to the 0 power is equal to 1. And this is our base. It's base 10. We're going to have the same thing in binary, only we're going to run on base 2. So binary, bi for binary, like a bicycle, is base 2. 2 wheels on a bicycle. So we only have 2 numbers, a 0 and a 1. And with that 0 and 1, we can make up any number that we want to choose, but it's just going to look different than our decimal counterparts, which use the 0 through 9. So for decimal numbers, we had a 1 spot, a 10 spot, a 100 spot, a 1,000 spot, and so on. So 3,874. For binary numbers, we're just going to start out with 4 spots. We're still going to have a ones place, then we're going to have a twos place, then we're going to have a fours place, and then we're going to have an eights place. So just like when we had the number 17, or actually let me even lower that number just a little bit. Let's do number 12, as that's going to make a little bit more sense. That number is 1 times 10 plus 2 times 1. So to get the number 12 for here, we would need to put something in the 8 spot, and we would need to put something in the 4 spot. So we're going to put a 1 here. We're going to put a 1 here. We're going to put a 0 here for 2's. We're going to put a 0 here for 1's. So we're going to see that this is 1 times 8 plus 1 times 4 plus 0 times 2 plus 0 times 1. 8 plus 4 is 12. How does that sound? Let's take a look at another example here. Let's take a look at the number 14. In binary, we're going to have a 1 spot, a 2 spot, a 4 spot, and an 8 spot. So as you see, all these numbers double. This is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and what do you suspect would go here? 2 to the 4. So this would become the 16 spot. This spot is the most significant spot, or the most significant bit when we get to that. We'll talk about that a little bit later. So to get the number 14 out of this choice of numbers here, what do we need to put in? So we know that 8 plus 4 is 12, plus 2 is 1. 8 plus 4 is 12, plus 2 is 14. Okay, so we put in an 8, a 4, a 12, and a 0 over here. Let's clean it up a little bit. And just wait for my program to catch up with me. And slowly move back up. Okay, so again we have 14. So for the number 19, excuse me. So for the number 19, we're going to take a look. We have a 1's, 2, 4, 8, 16. Over here is 32. Next we're going to have 64 over here, 128. So we can make any combination of numbers that we want. We can do 119, we can do 1019, we can do 3019. Okay, so we're able with this base 2 system to go ahead and make any number that we need to create, just like we can do in a base 10. So 19 in base 10 is we need 9 times 1, 1 times 10. Here, we take a look at our numbers, and we see that 16 is the largest number that we have. There aren't going to be any 0 or any 32's that can be put into a 19. So if we do 19 minus the largest number that is either equal to or less than the number that we're looking for, which is 19, we're going to do a subtraction here. So 19 minus 16 is going to leave us 3. So we're going to put a 1 in the 16 spot. 8 is larger than 3. We can't do that. 4 is larger than 3. We can't do that. So these guys are both going to have zeros. 2 is equal to or less than 3. And I hope I said it the right way just a minute ago, because when I was looking for number 16, I wanted a number to subtract that's equal to or less than the number I'm looking for. So I apologize if I said greater than, but I meant to say less than. So if we put a 1 in the 2 spot, and then we subtract here, we have 1 remaining. And here's a quick tip. Anytime that you have a 1 over here in your 1 spot, your number is always going to be odd. So 16 plus 2 is 18. 18 plus 1 is 19. So the number 10011 in binary is the number 19. Let's do another one here. $37. 1, 2, 3, 4, 5, 6, 7, 8. And most times you guys are going to really just use 8 of these. Once you start getting beyond 8, the numbers start to get a little bit big, and there certainly are calculators out there to help you out, but this is a really basic skill, and you should pick up on it pretty quickly here. And we're going to wind down this video real fast here. So we have a 1, 2, 4, 8, 16, 32, 64, 128. So we're looking for a number that is less than or equal to 37. So 128 is not less than or equal to 37. 64 is not less than or equal to 37. 32 is. I'm going to put a 1 there. Here's our number. 37 minus 32 leaves 5. 16 is not less than or equal to 37. 8 is not less than or equal to. 4 is. Put my 1 over there. Turn that guy on. 2 is not less than or equal to 1. Put a 0 here. 1 is 1 minus 1. Nothing else to choose from. So our number, and sometimes breaking this up into 4s, 0, 0, 1, 0, 0, 1, 0, 1 is the number 37 in base 2 binary. We're going to do some more. Come on back for the next video. We're going to pause this one. We're going to stop this one. But stop by subnetting.us on the World Wide Web. For this video, other videos, other applications that you can use binary numbers for. Thank you for stopping by. You have a great day.